Topic 6.3 is about photochemical smog, which is the type of smog which originates from the ozone. So last time in topic 6.2 we talked about what the ozone is. It's the layer in the lower part of the stratosphere which absorbs UV radiation. But if that ozone layer gets pushed downward into the top portion of the troposphere, then what was a good thing becomes a bad thing. So in the lower part of the stratosphere, ozone absorbs UV radiation, but in the upper part of the troposphere, it actually creates pollution, which we call photochemical smog. It forms here by a reaction with other sorts of chemicals, so it's a secondary sort of pollution with what we call volatile organic compounds, VOCs, like carbon monoxide or carbon dioxide, nitrous oxide, sulfur dioxide. So altogether, we get a smog. And the real question is, what is causing the ozone to be pushed down into the troposphere? So let's remember what the difference between primary and secondary pollutants is. Primary means there's no additional chemical reaction that's going on there. So let's suppose out of your car exhaust, you're getting nitrous oxide, nitrogen dioxide, or sulfur dioxide. Those would be primary pollutants. But then the sunlight breaks it down to release oxygen, and this forms ozone. And ozone can then become a secondary pollutant. So smog will be a mixture of primary and secondary pollutants. What's the effect of this? So the effect is bad. So when ozone was up in the stratosphere, it was good. Now when it's down in the troposphere, tropospheric ozone, it's bad. So ozone can enter leaves, decreasing the storage of food. It causes respiratory infections in animals and humans. And it damages lots of products. So economically, this has a really bad effect. Now it's more common in high pressure climates. Why is that? Because the high pressure front is what's pushing the gases down from the stratosphere into the troposphere. This would be more common in high population areas, urban areas rather than rural, in dry seasons rather than rainy seasons. Rainy seasons are typically low pressure fronts. And this would happen in deforested areas. So in other words, what's happening is you're having a temperature inversion. Weather is being pushed downward, and that's why, unfortunately, on really otherwise nice, sunny, warm days, if you're in a city area, it tends to get very, very smoggy. So let's just review what's going on there. High pressure causes a thermal inversion by pushing the high pressure air, pushes gases downward, so it pushes the ozone from the stratosphere down into the troposphere. Well, what can we do about this? Well, we've gone over these things before, and it's the same stuff. It's fossil fuels. We're putting too much carbon dioxide, which is then mixing with the ozone in the air to do a secondary pollution. So let's reduce the amount of fossil fuels. If it's a warm, hot day, we shouldn't be driving our cars that much. We could have cars that have better efficiency, that don't put up as much primary pollutants from the tailpipes. Emission standards would help that. And certainly if we had less urban environments, more greening of the areas, we wouldn't have that problem either. So that's just a quick wrap up there on topic 6.3 of photochemical smog.